Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over a couple of example problems, practice problems on how to use the information they give you in a problem to do a transfer of energy, to figure out like how to find certain things like a mass, an unknown mass, or a final temperature, or things like that. Alright, so the thing to remember is with any of these problems, the formula that I would like you to use is this 0 is equal to Q1 plus Q2 plus Q3 plus and so on. So these are where you're going to get heats, amounts of heats that are transferred from one thing to the other. Okay, so in this problem, you have a 32.5 gram block, aluminum block, and you're given the initial temperature of 45.8 degrees Celsius. You then are going to take this block and put it into water. So you got 105.3 grams of water, and the initial temperature of the water is 15.4 degrees Celsius. And so the information that they have to give you is the specific heats of the water in the block. So let's write that down as well. So the specific heat of water is 4.18. So we'll write that here. So specific heat of water is 4.18. And again, it's going to be joules per gram per degree Celsius. And then over here for the aluminum block, aluminum is going to again be 0.903. So the specific heat of the aluminum block is 0.903, again, joules per gram per degree Celsius. And so if we use our equation, so 0 is equal to Q1. And we only have two things in here. We have the block and we have the water. So our Q1 is going to be water, so QW, plus, and then we have the aluminum block. So I'll say Q aluminum. Okay, so now we have to figure out what expressions can we have that are going to give us these Q values. Well, we have the specific heat. So if they're giving us the specific heat capacity of both substances, then given the fact that we have joules over grams per degree Celsius, we need to multiply by mass and a temperature change to get joules. So each of these is going to be expressed by Q is equal to the mass times the specific heat times delta T. So then that means that's going to be, if we represent this, the QW is going to be the same equation. So that's going to be the mass of the water multiplied by the specific heat of the water, and then multiplied by the temperature change. So we'll do temperature final for the water minus temperature initial for the water, right? So that's going to be the first part. And then we have the aluminum. So we add that, the same thing. So we're going to use the same equation, but this time everything is with regard to aluminum. So we have the mass of aluminum multiplied by the specific heat of the aluminum, and then again multiplied by the change in temperature. So final temperature of the aluminum minus the initial temperature of the aluminum. And so there's our equation. So 0 is equal to this plus this. And so now all we need to do is just plug in the information that we have and solve for the missing part. And the missing part here is going to be the final temperature. And the thing to keep in mind is that the final temperature for both the water and the aluminum are going to be the same, because that's when you reach thermal equilibrium, is that when the temperatures are the same for the block and the system and the surroundings, the block and the water. So this means that the final temperature of the water is going to be equal to the final temperature of the aluminum block. So those are equal to each other. So we could just say that the final temperature by itself, so TF, right? We'll just say that both of those are equal to TF, the final temperature. And so we only have one unknown, so TF and TF are unknown. Everything else we know, so we could just plug everything in. So we got 105.3 grams times the specific heat capacity of water, which is 4.18 joules per gram degrees Celsius, right? And then we have final minus initial temperature. So final temperature, we don't know, that's what we're looking for, minus the initial temperature of the water, which is 15.4 degrees. So 15.4 degrees Celsius plus, and then we have everything for the aluminum. We have 32.5 grams. So we have 32.5 grams times the specific heat of the aluminum, which is here, so 0.903 joules per gram degrees Celsius, multiplied by, again, final minus initial. So here we have T final again, minus, and then the initial temperature of the aluminum block is 45.8, so minus 45.8 degrees Celsius. So now all you need to do is just solve the equation for TF. Okay, so here it's just more of a math problem. So now you multiply 105.3 times 4.18, and then equals, that's going to be 440. So that's going to give us 440.154. This is 3 sig figs, this is 4 sig figs. So our last significant digit is there. That's going to be multiplied by TF, since we're going to multiply this throughout. And then this is going to be, and then we multiply that by 15.4. So we'll multiply by 15.4 equals, and that gives us, and remember, this is grams times this. So let me erase that. This is going to be, the units are going to be joules per degree Celsius times TF, and that's going to be minus 6,778.3716. And then again, this is multiplied by degrees Celsius, so this is going to end up being joules, right? So then that's that, and then we do the same thing over here. So if we do this one, then we're going to have 32.5 times 0.903 equals, and that's going to give us 29.3475. And again, we're grams times grams on the bottom is going to give us joules over degrees Celsius, right? So grams cancel out, and then again, this is going to be multiplied by final temperature. And then we're going to multiply this out with the 45.8. So we multiply that by 45.8 equals, and that's going to give us a negative again, so negative 1,344.1155, and that's going to be joules again, because the degrees Celsius cancel out as well as the grams. Okay, so keeping track of our sig figs. So here, this is 3 sig figs, this is 3, this is 4. So again, this is going to be 3 sig figs here. So the second 7 is the last sig fig there. Again, 3 times 3, so this one's going to be there. That's the last one. And of course 3, so that one's going to be the last one. So keeping track of the sig figs. Okay, so now at this point, you're going to be subtracting things and adding things together. So the TF is going to be added together. So let's add those together. Okay, so if you add those together, so we have 440.154 times TF, and then that's going to be plus the 29.3475 equals, and that's going to give us, so again, this is again equal to 0. So that's going to be equal to 469.5015 joules per degree Celsius times TF. And then we're going to add the 2 negative joules together. So that's going to be 67788.3716. You don't have to add all of these digits. I'm just adding them together. So 1,344.1155 equals, and then that's going to give us 8,122.4871 joules. And that's equal to 0 again. And so now what you're going to do is you're going to bring this over. So you're going to add to both sides plus 8,122.4871 joules. Add plus plus 8,122.4871 joules is equal to 9.5015 joules per degree Celsius times TF, and then you divide both sides by joules by this over here. So then what you get is you divide this by this, 469.5015 equals, and then what you'll notice is when you divide this, the joules cancel out and you're left with on top degrees Celsius. So the answer you end up getting is TF, the final temperature is equal to 17.300, so on, degrees Celsius. And so then you have to figure out what you're allowed to keep. So here, when we added these together, right, these and these. So the last one was 0.3. And here we add this. So this, because we're adding, we're paying attention to decimal places. So then this value here that we had when we added this together with this was this one here. And when we added this one and this one together, they're both at the tens place. So that's the last digit that we're allowed to, because we're adding and subtracting. So then that would be this one here. So now, when we're dividing, we're paying attention to this one and this one. So this has 3 sig figs, this has 3, so the magic number is 3. So 17.3 degrees Celsius is what I would have as an answer. So thank you very much. I hope you like this video. See you next time.